Hello and welcome to the Scientific Adventures of the Beard Man. Today we're going to take a look at a skill, they call it, on positivephysics.org. It's in Unit 19, titled Electric Force, and the title of the skill is Conservation of Charge. So the basic idea that we're looking at here is that charge is conserved, which means that charge can't just increase or decrease. The charge of the universe is fixed, you could say. So when something has a change in its charge, like our socks in the dryer become charged, that charge has to come from somewhere or go somewhere. It can't just appear. So in the dryer, charge moves from things like silk to things like cotton, and they get opposite charges because the electrons have moved. So when one object gains more negative charge, those electrons had to come from somewhere. It can't just poof. And so they had to come from somewhere to make it more negative. That would make somewhere else more positive. Let's take a look at how that works in these situations. So we can see here that that we have a starting setup, which is labeled here. This indicates 7 electrons worth of positive charge and 2 electrons worth of negative charge. So in other words, this one has more electrons than protons. This one is missing an awful lot of electrons, 7 electrons to be specific, so it's got 7 extra protons. So what's going to happen? Well, the electrons are negatively charged, so the electrons will flow. We'll make them red, why not? The electrons are going to flow from the thing that is more negatively charged to the thing that is more positively charged. Okay? So as electrons leave this one, it's going to become more positive, and as electrons arrive here, it's going to become more negative. Okay, we can see here that we went from having a +7 to a +2. That means we had 5 electrons arrive during this process. Okay, because once again, we're missing 7 electrons for neutrality here, and now we're only missing 2. That means 5 electrons moved, which means 5 electrons shifted from one to the other, which means that this one lost 5 electrons. Well, the first 2 that it lost made it neutral, and then it lost 3 more. So that means it's going to end up with a +3 charge. Let me just say that one more time. Started out with 2 extra electrons. 5 of them moved. So the first 2 brought it to neutral. And then the next 3 that left protons that were all by themselves. In other words, a +3 charge. Okay? You can always double check your work by adding up the total charge. Here we have +5, +7, ±2 gives us +5, and here we still have a charge of +5. Then you'll notice the question over here, which of the following best describes the path the particles take? And you'll see an option that talks about electrons flowing or protons flowing. And of course, we will only choose electrons to flow because electrons are in the outside part of the atom. Protons are in the nucleus. They're trapped there. They're not going to be moving around. And you can see from our little arrow here, the electrons were going to flow away from the negative towards the positive. That is the leftward direction. So we'll say that there's a net flow of electrons to the left. Okay, so you look at which way the electrons would flow and keeping in mind that they're negatively charged, and that's how you'd answer that. Then you'll have some very similar questions to this, but notice that we don't see anything about the end. Instead, it says that they reach, it's underlined here already, I guess, that they reach equilibrium. So that means that both charges are the same, which, if these are the same size, that's what would happen. They would run back and forth, the electrons moving away from the more negative one until they reach a place where they were both the same negative one and they didn't have a place they preferred. So if we're going to reach equilibrium and we've got 6 extra electrons here, we're missing 2 electrons here, well, then that means our electrons are going to go to, let's do electrons to the right. Okay. And how many electrons are going to go? Well, you can kind of just, you'll get so you can do it without doing this, but let's start by just subtracting one at a time. So we go to -5. That's going to take this to +3 because that electron that left here paired up with an extra proton here. So now there's only one proton without a partner. Okay. And so then we go to -4, and that takes us to neutral here. We aren't at equilibrium yet, so we go to -3 and -1. And finally, we go from -3 to -2, and that electron moves over to this side, and so we're at -2. So it looks like both of these are going to end up at -2. When they're the same, it's reached equilibrium. All right, the final kind of problem you'll see is one where it takes a charged particle or object and it splits it into 3 parts. Well, this is our before, okay? So we know beforehand there is a total of -5. Afterwards, there must still be -5 total. Okay, so we can just add them up. +2 minus 3, that's -1. So we're going to have -4 more to reach this total. All right, which reminds me, there was one other thing you could do back on this one, and that is check at the end and make sure that our charge was conserved. We had +2 and -6, that gave us -4, and here we have -2 plus -2, which also gives us -4. One other way you could do this if you wanted to go even quicker, we'll make that blue. Quicker. With an E. All right, is get the total here. So the total here from both of these is -4. Okay, so we know that has to be the total at the bottom. Well, if that -4 is split evenly, just divide it by 2 and put half of it in each place. That was supposed to be an arrow. My finger doesn't always fit perfectly in there. All right, so enjoy puzzling out those problems on positive physics, and we'll see you next time on the Scientific Adventures of Beardman.